Hey, Coffee Compiler Club. Here today to talk about compilers and language runtimes and whether or not audio works on random Linux systems. And I'm facing out my windows a giant ass winter storm. So, if a tree falls and the internet cuts, that'll be the end. I don't have any set agenda. Anyone want to say something? I was going to get chapter 17 done this week, but it hadn't happened yet. So it's all but done.
So if you get a new PC, will it be Linux and will we have more Zoom calls?
That's a good question. This one is not showing signs of death, so I don't have to solve that question yet. There's like no chance I'm picking up Windows 11. I've only ever heard bad things about it. That means getting a new Windows PC with Windows 10, which will end of life before long, and that'll be hard to do, although 1,000 people will backport you to Windows 10. Or bite the bullet, get Linux, and then give up on my precious games. I have 1,000 games that I can't play on a Linux system. So
Because I stopped using Windows 7 when they stop us giving security updates. So that's what got me to Linux. And besides restarting the browser a few times, it's been roughly okay.
sure, like I said, I don't have to answer that question yet.
Hmm.
Not a thing, not
You
yet a
can
thing.
try you can try Steam on Linux.
Yeah, right. And maybe the situation's better now. If Steam forces the game devs to have a reasonable Linux port and set up and the drivers are all stable.
Hmm.
Watching Levo just have his sound fail on the first cut and restart and it works tells me that it is not stable yet. It's only been 20 years.
Hmm.
Oh, I know. All
It's
right.
I
been
thought multiple people here uses Linux, and
yeah.
I haven't seen some of you have any issues.
I've
I have
no.
I had been using Linux for maybe 12 years, maybe more. So it
Yeah,
And
doesn't
your setup
you
seems
never
good.
have audio issues, as far as
yeah.
I know.
What's
It's the
your
most yeah,
what's your distro?
distro Linux Mint. So
Linux Mint.
Mint, yeah.
Okay.
It's the
Yeah,
most stable thing I know. Yeah.
Linux Mint is a good one. Yeah,
Okay. Not
There
one of
there are
the
a bunch of
common ones.
nuance.
Fine.
Yeah, there's a bunch of nuance, but I stick with Linux because I know it best with Mint. So yeah.
Okay. So I
yeah, I'm
have
ready for the chapters. I was just trying to make a joke.
Mm.
I have a modest amount of compiler news on simple, and that's
Oh,
if you have a program that is it's a reducible program graph, reducible call graph, and all your loop nodes are labeled. So all your loop heads are labeled. You know the heads of the loops, and you know that's a reducible flow graph. Can you annotate every basic block as to which nested loop it belongs in, sort of incrementally on the fly using that information? And the answer comes back as no, you cannot. You have to run a full graph walking algorithm that does some sort of pre-order, post-order checks to decide whether a basic block is in or out of a loop.
why?
Yeah, exactly. That took me a while. I don't have any good way. I need a way to like draw a graph that shows up on Zoom, other than me holding up a piece of paper with
There's a site I will share it for diagrams, so you can try to work with
where
that.
where is this?
Draw.io maybe.
Where is
Uh,
this?
I will share draw.io, but I will share the
Hang
link
on, let me
maybe.
put the share on.
Hmm.
Yeah, you can do it. Draw.io.
Yes.
Let me go see if I can find that and figure it in live in real time.
Yeah.
Worthy of thing there. Let's see here. It says no script doesn't live you. Let's try again. Um, Save diagrams too. I have to pick a save device to
Yeah.
cite later. Thank you.
Yes.
Here is a diagram. Let me share my screen and see if I can draw on it.
Hmm.
And then see if I can draw a test case that's like actually reasonable.
That would be interesting.
Yeah, right.
Hmm.
So connection arrows, grids, points. I just want like some little guys here. What am I going to do? I'm going to do one of these, and then I need another one. And how do I get an edge?
It's the little dots that are blue dots. You can connect them, and it will make an edge.
It's the other way. Stop. Okay. Now how do I get rid
Con-
of this? Delete.
Control
Thank
Z.
you. Gotcha.
Oh,
Whoops.
oops.
Here.
Yes.
Okay. Be nice if it
Bigger.
was curvy, a
Oh.
little better.
Hmm.
I need them all different sizes. I guess this guy got shrunk by accident. Don't care. Okay. So then I need like three more here. So, oh, all lines. Hang on. Let me figure out how to make all lines fucking curvy instead of just the one I'm drawing at the moment. Can't do it. I'm not too slow. So this is a loop. Give me some text here. Loop header. It's got some backage it's missing. I haven't drawn. Here's a loop header. This line, how do I add text nearby? I want a text blob, text. Oh, how do you want to say? I want to say a cloud graph, a puffball, and much graph. It's a bad way to say it. But right. So imagine it's not one edge, but it's a huge wad of stuff.
Mhm.
Then I want to change this guy to be one of my tests. A little easier if I do this. I'll leave that in there. Let's see if I can get a test out of here. And we'll put an if, and we'll do something here and something here. And I want an edge from here to here. I want an edge from here to here. I want an edge from here to here. And then I want an edge from, here to here. And it badly wants to be curvy and spin out to the right. And
You can try to move it. Yeah.
yeah. And an edge from here to, nope, stop, come back. Yes, to here. It wants to be curvy and spin out to the left. Kind of ugly looking that way. Dude, oh, yeah, here, how about this? Maybe this? Better?
Hmm.
Okay, so in this picture, we're going to assume that this is sort of arbitrary graph. It's not a single node. And here and here. And when I walk from somewhere in the middle, if I've arrived in my walking to this if, and he splits left and right, the first node in this arbitrary graph on the left, that will be on the outer loop. And the first node in the arbitrary graph on the right will be on the inner loop. At the if, I have my predecessor, which is some arbitrary pile of graph that's infinitely large. And I have a node on the right and a node on the left. And one of them's in the loop and one of them's out of the loop. Whereas up in the arbitrary graph, I have many ifs who have a left and a right, and they're all in the loop because they're all part of the inner loop. This if is special. Oops. Hey, stop that. Oh no, how do I undo?
Control
Sorry,
Z.
I don't want to save. I'll just drag
Control
it,
Z.
but there needs
Yeah.
to be an undo somewhere. So the rule here is I have to tell it this if is special, that he makes a choice between in or out, and furthermore that I can tell which one's in and which one's out. Now
Hmm.
this whole structure itself is nested inside many other loops. So they're not like all the way out to the outermost loop. They're just
So,
out one layer or not out one layer.
question, would
Yeah.
it be much easier if you have source information about the loop?
So one of the things I can get out of simple and not out of other programs is that I nest my loops syntactically, and I can just carry. I know which loop is in and which loop is out. Like I know I'm parsing a loop in simple, and when I'm parsing another loop, I know it. But if having built such a structure and there's lots of dead code and a bunch of control flow goes away, I can start from something much larger and more complicated that's not obvious and get down to this, including having a lot of other loops that are just dead and go away as part of the process. So after all the dead code is done, I still am reducible and my loops are still marked correctly, but there's no correlation between the syntax I get when I'm parsing the graph. So the source code is sort of meaningless. By the time it gets down to where I'm looking at what a loop nesting is, the source code doesn't carry that information. So no, the source doesn't help.
So why doesn't carry the information where the loops start and
It
end?
did. So imagine that I had a very large program and it's nested 100,000 loops.
Okay.
So here I'm at loop, 1023, and here I'm at loop 2077, and all the other loops in the middle got killed and were removed.
Hmm.
So the distance between the loops syntactically and the loops in the final program are like arbitrarily large.
So we have to have the ability to mark what is live and what is dead. Will
Well,
that
you
help?
get that from doing the normal people optimizations. They decide things
Mm-hmm.
are dead and they start throwing things away, and that's fine.
Mm-hmm.
And that happens all the time. And I'm kind of being a little hyperbole, but not really. The fuzzer easily produces this kind of brutal thing where he's many 20 or 50 deep without any trouble, of which 90% go away.
Mm.
So this situation totally arises where the source code is just not helpful. And that's why I'm saying I have to have I have to sort of run an arbitrary graph theory. I mean, I have to run a real graph theory here that the decision point if down here is arbitrarily far from either loop header or the back edges, where arbitrary graph is any amount of if then else nested structured whatever in all directions. And you can't get this by some sort of local looking about. Um, you can't actually get it even if you have immediate dominators handed to you for free because the decision point's still not obvious.
Mm.
So
So you have to, in order to be, you have to be able to ask the question where the, at what level, uh, at what level you are in which loop. So where the nesting is.
yeah, I'm trying to ask the nesting level. So I come to a live range. I'm doing register allocation. I come to a live range, a use of a value that's inside this arbitrary graph section, and I'm out of registers. I have to spill. The defs are far, far removed, somewhere above in my 1,000 other earlier loops. And I want to split the live range at the loop entry of the nearest enclosing loop so that other live ranges will spill around the loop and I'll have registers in the hot inner loop. So I'm looking for loop borders and for what things are in which loop so I can tell you that, this is trying to get a line here. Boy, he won't give me a line.
He got it. It's in the middle. It's in the middle
Oh,
micro.
geez, I see.
There are two.
Yeah, I was just trying to say there's a fall into this. There's a fall into that loop. And
Mhm.
more of there's two of them because I hit it twice because I was trying to see it. And done. Anyhow, all I'm saying there is the decision points are far removed from where you need the information that you need.
Mm. Mm.
And the fix is it's some variant of Tarjan's, like strongly connected loop finder doesn't help here because it's all in the same strongly connected component. I want nested loops. So I have to run something that's sharper than strongly connected components. And I ended up with this is what C2 does. And I looked at what I was doing for C2, and sure enough, I took Tarjan's algo and then I modified it um, to deal with this. And I use
How?
pre-order numbers. I do a walk from the start. I do pre-order, and you give this loop guy a pre-order number. He falls his one out edge. You give him the next larger pre-order number. Bunch of pre-order numbers come here. You get to this if he walks this direction, and he eventually hits this and comes back. Everyone gets a pre-order, and he walks this one, and he hits this, and he comes back. But when the back edge is found, and it will be found, the tailing of the graph going backwards, unwinding the pre-order will tell you that you're in the inner loop. And this one here will tell you in the outer loop, but it won't tell you which one's inner or outer yet because he doesn't actually know. He just knows this arbitrary in the graph on the left is in the loop headed by here. Graph on the right is in a loop headed by here. When the if comes, he can look at the pre-order numbers and tell you the loop headers and tell you which one is inner and which one's outer, and then he'll make the call. Oh, this way is inner, that way is outer. I have to be in the tighter enclosing loop, so I'm inner as well. And then this graph finally decides he's all inner, or he's all with this loop. So I say inner and outer. What really has is I want to associate a node with a loop or some piece of program graph with a loop header.
Mm-hmm. So,
And
so it sounds, yeah. So it sounds not so complicated, but it's a way to enumerate the loops inside using the basic blocks or using the nodes.
it's basic blocks.
Hmm.
Like I'm drawing control flow graphs, so it's basic blocks. So you can pick out a basic block out of a sea of nodes directly. So
Mhm.
that's just a filter on the nodes that keep those CFG nodes. And there was another thing I was going to say here. Oh, and the other thing then, yeah, is that I end up building the loop tree from the inside out, from the leaves to the root. That is, when I visit this guy, I know he's going to be a loop tree member, but I don't know where he fits in the tree. When I visit this guy again, and this could be arbitrary graph I don't have shown in the middle here along that edge as well. Fit this guy, I don't know where he fits in the loop tree. Then I work my way all the way down, and I work down to this one side here, and the pre-order lets him detect that he went backwards in the pre-order numbers. So that's a loop header right here. Okay. So these guys all belong to this loop. And in this picture, it's the leaf of a loop tree, but I don't know where it sits. Then back when I've unwound back to the if and I go forward again in the pre-order for this set, they don't know what loop till they hit here. You unwind, they all agree that they're all with this now outer loop. When you get to the if, you get the decision point. Oh, I have two different loops. And using the pre-order numbers, I can sort them inner to outer. So I go back to my loop headers and I make them point in the correct loop tree way. And then I can keep unwinding the pre-order numbers or the pre-order post-order
So
loops.
what I heard is that you distinguish them by the loop headers and back edges, which are basically the skeleton of a loop inside the
Yeah,
sea of nodes.
yeah.
Okay.
And the pre-order numbers. The
Hmm.
pre-order numbers always go backwards when you hit a loop.
But
But
how do
like
you know the back edge points to this header loop?
yeah, you find a back edge. You can tell it's a back edge because in C2 where I don't have loops found yet because Java produces arbitrary graphs,
Hmm.
I use the pre-order numbers. Turns out it's the same as using the loop node, which simple with a reducible only program will just directly give me.
Hmm. Hmm. Hmm.
But in either way, I have to ask the question. I need the pre-order still to sort the loops inside and outside.
Hmm.
So that's non-obvious as it goes. So this is one of the failures. There's another nearby related failure for which the if gets the apparent identical looking graph, but they're not nested at all. And that's why you have to have the pre-order numbers. Is that
Hmm.
this one I might be able to do sleazing my way along, but I have another version that exactly counters it that doesn't nest, that you can't tell without pre-order numbers, which means you have to do a full graph walk of pre-order numbers. And on the post portions, you add or build up loop trees. And then when they're done,
C2 have it harder because it gives the Java graph is not it's not that structured or
yeah, like Java is structured and then except to do try finallys. And then
Hmm.
the finally clause, an exception throw will get you out and give you a second or third, give you a weird exit out, but then it gives you a weird entry into the handler, the next layer up. So if you have tries with inlining and multiple nested try depths with inlining and handlers, it goes irreducible.
Hmm.
So pretty quickly you get irreducible graphs, and then dead code elimination kills a bunch of paths, and the graph is essentially arbitrary. I think someone's long ago proved you can get arbitrary graphs out of Java code if you do some amount of dead code or dead path killing.
So the try finally screw the
It's
try finally
because
mix the graph.
the handler and the finally has everyone coming out of some point into the handler who is then inlined in something else. And I forget the exact path, but I have totally it happens
And
on every large enterprise program doing I/O where they have sort of an endless amount of try and catch IO
And
errors.
catches is introducing more and more irregularities. The
Yeah,
graph
irregular
becomes
edges. Right, right. And
okay.
then very quickly you get sort of arbitrary graphs.
Okay.
So
Okay.
now you've got arbitrary graphs, and they never were marked in the loop headers were never marked in the bytecodes.
Hmm.
So, what's a loop? Well, if you go by Java C patterns, you can pattern match your way to get to like 80, 90% of the loops. But if you're doing big enterprise level IO, you won't catch them. And those will be the hot ones that
Hmm.
are walking over large, file systems and trying to do things
And and how
quickly.
do you optimize something that you don't know?
Well, you have to find the loops. That's what I'm saying.
Yes. Okay.
So I don't get told loops. Simple, I get told loops. Java, I do not get told loops.
Does it does it see to find them uh, always find the loops or
Yeah, this is the algorithm from C2. I pulled up my old C2 code. It's like, what did I do here?
yeah.
Oh, I have a modified Target algorithm using pre-order numbers.
Mhm. Okay. Okay. Cool.
And that, yeah, so I stared at it for a long time, and it handles a bunch of other ugly cases that actually simple might get closer to, like uh, unreachable infinite loops, not unreachable, infinite loops that you could reach, but they don't exit ever. So they messes with your pre-order numbers. Um,
Like an event loop, maybe, or the
Yeah, but it's just somebody wrote some bad code,
hmm,
and then there's a path that even maybe I can't tell, but it never gets reached, and it would just loop infinitely if it gets reached.
hmm,
And then the compiler recognizes that if you fall down this path, you're going to be spinning an infinite loop, and maybe it's an event loop. So yeah, so maybe I should leave it. I should optimize it. So he
hmm.
runs around, tries to optimize some of these infinite loops. Some of them make sense, some of them don't. In the case of
Okay.
simple, if I want to have a loop nesting depth loop tree just for register allocation and some amount of loop invariant code motion scheduling things, but register allocation, um, immediately I get, infinite loops. The fuzzer produces them in droves. But even if the fuzzer wasn't, they're going to happen and it's going to crash. So my option are is the optimizer crashes if you write infinite loop, or I have to handle it. The easy handling says if I know the loop nesting depth, I can do something. Here I am trying to find the loop nesting depth. So C2 in this algorithm where he finds the loop nesting depth also handles infinite loops because there's a phase ordering problem. I can't, this program, the algorithm I just told you sort of verbally has an interesting issue with an infinite loop in that he fails to come up with who's inner and who's outer when staring at an if choice that's picking between two dead infinite loops. He'll just crash on you.
Hmm, hmm,
Give
hmm.
me the pre-order one. Neither one's pre-order than the other. So they fail to pick or something. There's a place where I'm now looking at it even now. You get a null, no choice was made. I crash because I don't have a choice, so I don't know what loop I'm in.
So you're
Oh,
talking about
that's the graph I can make.
that's the case that the two infinite loops nested inside each others, or they do not have anything to do in common.
Uh, I can arrange that your loop has multiple back edges to a shared infinite loop header.
Hmm,
And then he's busy trying to sort which one's inside and which one's out. And of course, neither is because they're on a shared header and stuff. So
hmm.
I have a little bit more complicated graph. This is where I'm stalled on 17. I stopped last week at 17 because I kept hitting these funny cases in the looping algo. And I did other things for a while. I've come back and I've sorted it down to there is no easy answer. You have to run the pre-order and then you have to
Hmm.
handle infinite loops. And that's what
So
C2 did.
Simple will have some version of this pre-order and this enumeration algorithm. Hmm.
I'm sorry, what about the pre-order?
Simple will have
Yeah,
the something like C2 the loop
I'm
enumeration.
I'm I'm mid. I mean, I'm mid hack. Let me throw up mid hack.
Hmm.
Uh, Actually, this guy is probably easier to show. Let me do view things here. Hang on.
Yeah, zoom a
Zoom.
little
Yeah,
bit.
go find the zoom here.
Mm.
Okay. And
That's
then, oh, I can't find buttons. Everything moves. Go away. It's a little easier. So left-hand side, maybe. So something about build loop tree.
mm,
And I have a pre-order numbering. So here's an array of pre-order numbers. I didn't put pre-order numbers in every node and make the code easier and add a field in every node. And I probably will because expressions probably ease of expression is probably better than faster. But test for am I pre-ordered or here or not? And if I am, just get out.
mm,
Set my pre-order number and it's negative to say I've not been post-walk, just pre-walk. Then I pre-walk. Here's your filter for just the control flow graph.
mm,
Go pre-walk. So when I'm come out of here, it's time to do post work. And now things are getting a little weird. Walk the outputs of a node. This could be that if that's a decision point, but it could be any random node, any region, any just piece of control flow lying around. If I am pre but not post, then I found a back edge. And I know that I must be a loop node. So I just cast it. It must be a loop node by definition of how pre-order visits work. If I'm
mm,
adding that guy and I walk backwards one edge, I walk my outputs one edge, one use edge, and I get a pre-order number and its pre-order is not yet post, I must be a back edge. So then I say, oh, okay, you're a loop tree header. Here's the head of your loop tree. It's a loop node. And I'm going to claim it goes onto this guy, onto my use here, my output guy. And that's the current loop tree of interest. And I'm going to collect them. If I'm not, in my post order, oh, I must have had a loop tree. So I go ahead and get it. And I assert it's not null, except in the weird case that I don't like, which is the algorithm's in the middle of. The parser hangs on to a couple of dead control nodes uh, for ease in parsing, and they trigger every assert in here. It's ugly, so I don't like that. And
mm,
it could be that the guy I just grabbed is actually falling into the head of a one deeper loop, but he's not the deeper loop, so he needs to be the parent. So there's a lot of little subtle, complicated things. Once this decision point is made, and I have a decision of the loop tree of the use, I
t-
now present this sort game where I look at the inner and the outer based on their pre-order numbers. So I grab the pre-order number from the one guy and the other guy, and then I make them positive, and I don't like my pre-order numbers being negative or positive or visit or not. So I need a visit bit and get rid of the math at absolute. And then if I decide I like it this way, then L tree at parent is inner, otherwise inner at parent is L tree. So I sort your loop trees right there. And then I've kept the innermost one in all cases, which eventually I assert that you're being set to it. I think some of these asserts are overkill.
mm. Do you have an example source so we can embed all of this happening? So
Well, this is like literally wrote this morning,
yeah,
last night, this morning,
okay.
sitting in my chapter 17 branch, not pushed.
Mm.
So I could
Because it
go
will be
push it. It's not complete. I probably will change the data structures because I don't like what I've done.
mm,
And I'll add the pre-order number on the control flow graph pieces, and that'll make it a lot easier. And I'll add a Boolean for pre and post walk somewhere. I usually do that with visit bits.
mm, 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 mm,
And as soon as I have a visit bit, one of the screwballs goes away here. The positive and negative thing goes away, and I just test is you visited or is you not here,
yeah, yeah, yeah.
right? And then again here, this will get rid of the absolute value guy, and it'll be loop tree dot self dot pre and loop tree dot self dot pre
Mm,
instead of node ID do a lookup in the pre numbers. So it'll clean up.
mm, mm, mm,
And then a lot of this stuff is highly redundant. I've just flipped left and right here on loop tree and inner. So I probably will clean it up a little bit. So he'll make a decision a little cleaner and then he'll sort left to right or right to left.
mm.
trying to think of all the things I would do to clean it up. So, I mean, I can go run you the test case I'm currently running.
Yeah, it will be easier to embed in some kind of source code.
I've not sorted out. Let's go look here. Okay, this is a dumb. Oh, this is an infinite loop one. That's I don't want to do this one. Let me do one that has a loop. Fuzz zero is pretty easy, but none of these have doubly nested loops. Let's do fuzz zero. Single nested loop, sort of obvious thing here. Oh, he passes. Boom. That's nice. Okay, so now let's try again. Okay, so this has got exactly one loop. It's all very dull and boring. It has nothing special. So I'm going to walk in here. Pre-order numbers. I start at the start. I set your pre-order number. It's going to be set right here. So start is node 2. He gets pre-order number -1. So first number is 1, and it's tagged as not post walk. Go find your control flow output. Okay. I'm about to go walk X control. X control is a bunch of special things. We'll walk it because it's stupid. He gets his pre-order number of -2 up here in my pre-order list. And then he goes and has no outputs. So fine. So go do X control. He has no outputs. So he comes down here. Nothing was picked. So he has a special cutout on the assert so I don't die. There's nothing going on in X control. And I'm done with him. And I change his pre-order number back to positive, saying it's a +2 there, saying it's been post. Done with X control. Well, that was very boring. So let's look at another guy here. So we need a next use is some control projection. This will be exciting. This guy sets his number. What's his pre-order number? -3. He got an output. Yeah, it's a loop node. Okay. We're going to go pre-order again. We're doing the loop node. He gets the next pre-order number. Next use, some fee doesn't count. If, there you go. He gets an if. This is the loop exit test. It's a pre-order number. I got a new control. One of these two guys is going to be exit out. And one will be loop back. So we're going to take a look. Set a pre-order number. I got to use the, so I'm currently at some control projection, but this is the true side. His use is the loop. This is the back edge. So he goes and walks to the loop. Now he's on the loop guy, but the loop is being pre-ordered numbered already. And this guy, node ID 13, the lookup here is gruesome. That's why I don't like this. -4. He's been pre-walked, not post. So I'm out. Do nothing here. So they get the other use. So shrink this back up. Will be the other side, and then I'm done. So I did true and a false, and I'm out. Boy, I skipped over one of them. And I'm doing the I walked the true side. No, I didn't.
The control projection distinguish the cases. Does it need to enter the loop or it doesn't?
Yes,
or
one of them exits, one of them enter. Let me flip to the draw.io. There's no way to go back and forth easily here, I don't think. So you can imagine a case where my start is here. I have a loop. I have one block with some data, no code. I have an if. He's got a true that loops. He's got a false that exits.
Okay, cool.
So that's the extent of the graph. This is not a doubly nested weird situation.
And that's are the control projections
yeah, so there'll be a control projection for true. Could be arbitrary complex CFG here. There isn't. And the true points right at the loop, but it doesn't have to. Same for the false. Could be arbitrary stuff, and then you'll point at stop. Instead, the false here points straight at stop. But when I pre-ordered, I started at start. I got a 1, pre-order 2, pre-order nothing here. It's like 3. This is pre-order 4. I went backwards. I found a 1. So it's a negative pre-order number. So therefore, it's a loop header. I come back to the true guy. This is where I'm at in the algorithm. I'll switch there. And then I'm done with the outputs of the true guy. So I'm now doing the post-walk work of the true guy. So we're going to go flip back to the debugger. And here I am in the debugger. I'm on the true guy. I'm about to do the post-walk work on him. And that's going to be look at his outputs and figure out what loop he belongs to. So look at his outputs. It's a loop. There's the use, says use is a loop. So is that loop pre or post walked? Okay, so it's pre, so it is my loop header. If it was post walked, I could be falling into a new loop, but here I'm looking at the back edge.
Mm.
I assert I haven't figured out what loop you are yet because you haven't been post walked. The loop node himself has not been post walked. So I'll make a loop tree entry. And loop tree is just this trivial tiny static class. It has a loop and a parent. Has a self loop, the loop header. Maybe I say self, I should say header, loop header, and a parent. That's all it has. Okay. Now I have a loop tree entry. That's my L tree here. And his L tree parent is null. He doesn't know what parent he has. So fine. So I'm done down here, and I'm now looking to see if I have two such things and I can pick between them. Turns out I don't, only have one. So that must be my loop. So inner is equal to loop tree. There are no more outputs. I have an inner, so it's not null. And I've not picked yet, so I just now pick it. The true side gets the inner loop as his loop tree set, and I'm done post walking, and I post walk. And I flag the post walk set here, which means that the 6 out on the end is positive now instead of negative. Post walk's done. And I got rolled out of the true side. I'm back to the if, and I'm looking at the other side, which is the false side. So the use here is control protection false. Going to walk it. It's not pre-ordered. It gets a number. He has an output, which is the return node. I haven't walked it. Go back through the return node. Pre-walk. Go blah blah blah. Output here is stop node. Okay, go walk here. Stop node hasn't happened. Pre-order. Okay, stop node has no outputs. Still has no outputs. So now your cert is your stop node instead of the control, X control. Fine. And then I'm going to be done with stop node. He has no loop because he's actually the outermost loop. Effectively, he's in no loop entry. Walking backwards one to return. Return has no other outputs. So let's go figure out what loop return is in. Walk his outputs. He's got one that's a stop. He asked Mr. Stop, Mr. Stop, have you been post walked? You have. You have a loop tree picked out. You do. It happens to be which one here? It's the start node. The start is now a loop to make my life easier. That is the loop tree. It's start. So I assert that I got one, and here am I at a decision point of left or right? Or I'm going to fall into a new loop or not. I'm not. I'm just part of the loop that is the start. Stop node is a giant loop. The whole program loop. It's not really a loop. What am I doing here? Do I have a choice made? I have not yet made a choice, but I have one picked out. So inner is null, so I'm just going to take it. So that tells my innermost loop is actually the whole program. No more uses. I pick something, I'm going to sign it in. So thus the return node gets told, you belong to the start loop, the whole program loop. And I'm done with return. Unwinding my recursion, I'm back to the false guy. He has no more output, so now I'm going to the false guy. So this is the loop exit test node. And the control projection is not the loop exit test yet. And he says, I have a use. It's the return. The return has been post walk. Return knows what his loop is. I'm going to pick it up. I'm not falling into another loop, so that's the choice. I have no other choices, so I take it. Any more outputs? No. I made a choice. The choice is set. Done. I'm equal to the whole program loop. I inherited that. So false side inherits it from return, inherits it from stop. They all know they're in the whole program loop. Done with that. Now we're going to hit the if test, which is something more exciting happens. He has no more outputs. So now do the post order work. I'm going to grab one of my two control projections out. I'm going to ask, have you been post walked? Yes, you have a loop tree. Looped tree is loop 13. That'll be the innermost loop. I've picked them randomly according to the ordering of outputs here, so I don't know which one I get. I'm not falling into a loop. I don't have any other choices, so I'm taking the one I got. I've picked the inner loop. Now I go to the other guy. It's the use is now the false. You've been pre-walked, post-walked. I have a loop tree for you. I grab it. I verify it. I like it. It's again, I'm not falling into a loop. Now I have a funny choice. I have an inner and I have a loop tree. I have a loop tree. I have an inner. One of them is the inner loop. One of them is the outer, effectively. I come down here and I ask the pre-order numbers.
Hmm.
So the start's pre-order number is like 2 or something stupid. 1. It's -1. And the inner guy, this is where I don't like having this, his node ID is 13. So I go to pre-orders, I go into slot 13, I see it's -4. So I have a -1 to -4. If there are 1 and a 4, the larger pre-order wins. So here I'm gonna take, I got the correct answer already. But that was the decision point of whether the if exited a loop or entered a deeper nest. He doesn't tell. He has two. It's all relative. He has 2 loops. He's going to 2 different loops. One's inner, one's outer. He doesn't know which is which. That pre-order test told him which one is which. Having made that call, he now builds the loop tree set. He says, okay, I had to make a decision. So I'm going to set my inner to parent and I'm going to keep the parent. I'm done with that. I have a decision. So I'm setting myself to inner. That means that this inner now has a parent of the start outer loop. And that was the decision of who was in and who was out. And then it's done. Everything else is kind of anticlimactic after that. I've unwound from the if. I'm on the loop. The loop has no other control. So I go his outputs. But he falls into the category of all my children have their decisions made. I'm just going to take a child decision. So I have a decision of a child, the child already in pre-walked, post-walked even. I'm just going to take it. I didn't fall into a loop. I have no other choices. I come over here, output, no other control outputs. I had one guy. It was the if. The if is the inner loop. Therefore, I am in the inner loop. I am the loop header of the inner loop, in fact. And in fact, if I look at this guy, I think I set him already. Right. So I already flagged him when the if made the choice, the if flagged him as well. So he's just setting his loop tree to identical value, and that's why the assert allows you to say no change. You either didn't know or I'm telling you again. And he's done with the loop. And then I'm back out to the dollar control at the start of the world, who's just going to say I'm going to fall into the loop. The same exact path through. My one child is the loop header. I am falling into a loop. Oh, here's a different decision. First time this happened, the dollar control at the start of the program, his one child is a loop 13, the nested inner loop, but he is falling into the loop. So therefore, he is not in the loop. He's falling into, therefore, he's out of the loop. So he grabs the parent of the inner loop, and that happens to be the outer loop, the start loop. And how did I know that? That was because I'm falling into the header. I'm post-walked. So here's this test. Hey, pre or post? This is -0. So this is pre or post. I am post-walked. Therefore, I have walked this other loop already. Therefore, I'm not part of that loop, or I would have been pre-walked in the middle of the pre-walk when I found the loop. Since I found the loop after the loop was completely done, I'm not part of the loop. So therefore, I'm falling into it. Therefore, I'm not in the loop. So I take the parent and I'm out. And after that, I have my decision made for the dollar control who has nothing else to do. So he sets himself to dollar control and gets out in your background to start here in a second here. Next start has a bunch of constants that don't count. And start will say, what is my one child? Well, as soon as I get to the child, and it's been post, it has a decision made already, and it's the outer loop itself. And he comes along and says, I have no other choices. So I'm going to take that one choice. So I've got some more constants here. What's the other one? Oh, I have an X control. Yeah, start has 2 children that are controlled. He has X control, who's also tagged to the outer, and he has dollar control. So that was my miss on that piece. All the constants do nothing. I'm pointing at the outer guy. I set myself to the outer. His loop tree is already set because he is considered a loop, and that was set when I discovered that a while ago. And it's done, and I'm done. I have a loop tree. And so now if I go to any random node in the graph, so input, return, input, any random control flow node in the graph. Inputs here, I'm just picking somebody. Here's an if. He has a loop tree. Loop 13 is the inner loop. It has a parent to the outer loop, the start. And he knows the loop header. And now I can ask the question, what is your loop depth? Which I haven't asked yet, but that does a lazy walk up the loop tree for any given node and fills in the depth. So that's what that is.
That's a really complicated way to find the loops without knowing where the loops are.
Yeah, you know, if you look at the Targin strongly connected components,
Mhm.
this is very close, except I am doing a little more work in the pre and post order walk.
Hmm.
The Targin guy does a pre-order walk, decides where the loop headers are based on that. But then he does a gathering operation where he just throws people he's found and keeps going. And I have this distinction I make between you went in another layer or didn't, according to, you know, you loopy or not.
Mhm.
And if you're handed an arbitrary graph, so not an arbitrary control flow graph, but an arbitrary graph, and you say, find me the nested loops in this arbitrary graph, you have a lot of sort of arbitrary choices to make. There is no clear guarantee of inside to outside. You can imagine an in-way clique of everyone pointing to everyone. It's all switch statements where every switch points to another switch, which points back to themselves in a giant, completely interconnected graph. What's the looping structure? Right. So I am imposing an inside-out looping structure based on what the user had written at some time in the past to tag loop nodes. And the fact that I'm reducible lets me get a decent job of inner to outer. If I was irreducible, I could still make the decision, but then it becomes arbitrary who's in and who's out. And C2 does like things with profile data.
What was
And
the quick version of what was reducible and what was not?
I'm sorry,
What was
what's
the quick
reducible?
and what's not? The quick
Yeah,
version of
okay.
that.
Yeah, reducible. Fine. Let me go pull up draw IO again here. This is like the tiny program is irreducible, and everyone who doesn't have this as a subgraph is not. So I have some, how do I get a dude here? I drag it, that's how. I have some dude. Let me whoops. How about no? Oh, he is gonna do it. All right, there's gotta be a better way to do that, but that's fine. Little space, drag and drop. Okay. Do to do lines. Where did I do lines again? Um, this. Oh no, here. That's right. Okay. So I want a line to here. I want a line. Well, okay, that's really bad. A line to here. It's not good, but that's because this guy doesn't do this. Other way. Okay, so that's pretty badly done, but you know,
Yeah,
what you
we,
gonna
we,
do, right?
we get
How
the
about
gist.
slant? Do you have a curvy? Maybe not gonna help it. All right, fine. So it's if this is your start
Mhm.
or arbitrary program, you have some sort of arbitrary program, and you got to this decision point, and an if test is made. So there's an if test here. Start block includes an if. Let me do that instead an if instead. He chooses to go left or right, and he hits these two guys, okay, and they're looping back and forth. Which one's the loop header? Which one do you enter first?
Based on
Well,
the if test.
yeah, you can pick which one is first you want.
Mhm.
So there is no guaranteed loop header here. And so under this situation, this graph is called irreducible. And that's because uh, you can't take chunks. A reducible graph has a series of graph rewrite rules you can apply where you reduce it by taking a simple pattern and replacing it with a single node. And you repeat this ad nauseum, you get down, the whole program reduces to one node. You can unwind and undo those many to one transforms that are all like simple pattern gets reduced to explode and get the same program graph back. What that means is if you run any sort of analysis over a reducible graph, it is possible to do
Wait. You can reverse it back. It means that it's deterministic in the.
No. When you reverse it back, you just have to do a stack of changes did going forward. You have to apply the stack and reverse coming back.
Oh, okay.
The only point of that one is uh, because the program is reducible, because you can reduce in these stepwise fashion, you can, instead of reducing, you can do algorithmic interesting work like who's a constant or what's larger or smaller or who's in or out or whatever. You can do that stepwise going in and stepwise coming out, which means there's a lot of algorithms that work on reducible graphs that do not work on irreducible graphs.
Okay, so irreducible here means that you cannot get smaller. You cannot.
This chunk has, no, you can't do these reducing steps. So the easy one for the reduction is I have an if diamond, I'm going to replace it with one. And I have a loop, which has a header and a body and a back to the header. And I'm going to take these two and make them a single node that's the whole loop. Usually it's actually the loop has a point to himself and just replace it with itself. So if I have just those two transforms, I have an if-else diamond and a reduce, and I keep applying those reductions till all my if-else diamonds have disappeared. Then I'll be left with a series of loops of some kind. And if I have a loop to yourself, like the innermost one will be himself, I replace him with a single node that's not looping. Then I have a loop of just an inner guy, and I can replace him and ad nauseum repeat until the whole program's done. Under that mode,
do I have to do something that's not structured programming to get an irreducible graph?
yes, you have to
Or
do something.
can I make an irreducible graph with just if and loop?
That is basically the definition of structured programming, is you can't write an irreducible graph. So the JVM bytecodes allow irreducible graphs. Java does not directly, but you get it in Java with try-finalies that have been inlined, and you have catch clauses in weird places. So every large, I want to say, enterprise program doing I/O, which is endlessly trying and catching I/O failures all over the map, will generate irreducible graphs, typically in the hot inner loops. After control flow elimination, after dead code elimination, dead test elimination has happened, you frequently get irreducible graphs. Not everyone, but you frequently get them. So C2 handles irreducible graphs by making them reducible by doing some code cloning. So this graph is irreducible, and that immediately says there's no distinguished loop header. So I can't tell you where's the head of the loop. And if I want to do loop invariant code motion, it's not legal here to hoist something that's in between A and B to either the A side or the B side directly. So you fix that by cloning code. So I'm going to put I'll put a fixed version here. We'll come down here with do this, and probably this. So I do something here. I need to move things around. I guess I'll do it with edges. So this is the if, and the if has a pointer to the A. I'm going to clone the A code, and the A has a pointer to the B code, and then the B code wants to point to, but here the if has an edge also to the B code. Let me make sure I can't do it. Yeah, I can't do it conveniently there. Okay, I do this. This is not pretty. Boom. Yeah, okay, come on, dude. How about this? Yes, a little better. Okay. Here's A code again. There's my clone. And then, of course, this guy's just a loop to himself here. Wow, that's really ugly, dude. Okay, so here I've cloned, and now B is the obvious loop header. And then, you either do one copy of the first A, and then B to A to B to A to B to A, or you skip the first A and go B to A, B to A, B to A. So it's semantically the same program. Now I have a loop header. Anyhow, the standard loop finding algorithms fail on irreducible loops for the
So
obvious
A is
reason.
identical. It's a copy of.
Yeah, I've cloned A. It is identical to the prior program, except it now has a distinguished loop header. And if I have loop invariant code motion between B and A, I can hoist it up into the first A block. Whereas in the other program, I don't necessarily have that place to hoist code.
So do you measure the size of A and B and then just clone a smaller one?
In C2, I use branch frequencies to decide which one's the actual entry.
Oh, okay.
I'm willing to unroll whole loops, unless they're ginormous, in which case I give up on a lot of things. But if they're not ginormous, I'm willing to unroll a whole loop. So any partial loop, so A and B together is the whole loop. So any partial copy of AB is fine. And then when I'm done in the bottom case where I have BA, if that run together isn't too large, it'll get unrolled.
Uh-huh.
But if I want to, do loop invariant code motion, I can't on the first configuration. I can on the second. This is compiler graph theory. I'm going to say 101, but this is all like grad level. I don't know what people teach in data structures these days. I don't know they teach this in undergrad. This is probably grad level data structures course. But they show up in compilers all over the place. I do lots and lots of graph algorithms. And like I said, the ones I have in C2 are, I'm going to say, unique. They're very limited published work on this. I've been hunting around for like other things, and it's not widely published. I would have thought it would have been widely published. Or Google Scholar can't find loop restructuring papers from the 70s and 80s. This is like 70s and 80s. People sorted this shit out. Fortran was like, hey, all the loops are obvious. And then after a while, Go-tos and, oh, the loops are not obvious. And then we screwed around and said, well, don't write your loops that way and structured programming, blah, blah, blah. But it still happened. And so some theory came along and said, hey, this is a loop and this is an irreducible versus reducible. And it's exciting and interesting because analyses fail on irreducible that work on reducible graphs. And can we do something about it and so on?
Yeah, I feel like things spin. There was a lot of very linear structured programming stuff. And now I feel like the whole world's moving back to async await, which is basically just a bunch of jumps.
Yes. Yes. I'm not, I think there's a better answer than async await, but that's a whole nother game. And this stuff, if you fail to get it right, you'll generate crappy code. You'll either be incorrect, so you'll get the correctness right, or your code just won't run. But it'll just be crappier than hell, and people will hate you because all the performance is tied up in getting that hot inner loop to be correct. So it's actually still important to understand how this shit works and make it happen if you're going to do any kind of optimization. I mean, I know Adrian's not. You just like spew it out, first pass, go, run, done. But if you want some optimization done, you got to have some amount of, care taken. So simple doesn't have to deal with irreducible, but it does have to deal with the nested loops where the decision point is arbitrarily far removed from the point where you have the information. And then that turns into, oh, I have to have an actual algorithm there.
So a lot of these performance optimizations feel like you're in a world that mostly smells like one processor doing one thing at a time sequentially.
Yeah.
But we live in a world where there's lots of threads. Like,
So
what if you have a blocking call on a shared resource in a hot inner loop between two different threads?
Right. So this is not really a different story. So you have two threads. Why do you have two threads? Suppose I gave you one thread, but I told you it was 1,000,000 times faster than having a second thread. Do you need a second thread? You're 1,000,000 times faster. Okay, suppose it was only 100 times faster. At what point? 10 times faster, 2x faster. At what point did you say I needed a second thread? When I could just get the job done. If I had a 10x faster, if I have some amount of work and I'm too slow by a factor of 2, and I give you a 10x faster thread, then I'm 5x overcommitted and I'm just hugely fast and I don't fucking care about a second thread. It makes my life hard to have another thread. I got to the second thread because I had more work to do than I could get done on one node. And in all the cases where you look at this kind of thing, it's all about how much can I get done on one node first? Once I'm topped out on one node, or one core, now I need a second core. Okay, now I'm multi-threaded. But if instead I said, throw away your fucking microservices and get 1000x faster single core performance in a monolithic kernel, and then I don't need 1000 cores and I don't have to do 1000 concurrency things.
Right, but I feel like the trade-off is, so there's two ways I can write my code. I can have a very high level loop that dispatches a bunch of big jobs and work those jobs till they're done and then join them all together again, which means the developer has to decide what they want the concurrency to look like.
Right.
The other option is to say, let the developer write it as a ridiculously large number of ridiculously tiny tasks.
Yes,
And
very
hope
fine-grained
that you can
parallels.
simply
Yes.
inline away the fact that,
Right.
I can write it as if I have a sort of infinitely parallel machine and just
Yes.
trust the compiler to go from infinity
Right.
down to 8.
And
Or I can write it like I have an 8-way machine, in which case I have to write it like I have an 8-way machine.
well, I'm just pointing out that the experience has been the compiler actually doesn't fold away all those microservices very well. And you get a lot of overhead on microservices now. You could argue I have poster child where it works perfectly, and I have test cases that are great, and I have some experience here and there where it's not actually sucks really bad, and it's all over the map. I don't know that there is a reasonable way that you reliably get the overheads of expressing the microparallelism folded away that seems to work for everybody. I hear a lot of test cases, a lot of use cases
Yeah.
where I went to
I guess the thing
microservices.
I'm tripping over is I feel like I heard that exact same story in Fortran about calling functions. In Fortran,
Yeah.
people said make
Yeah.
big functions because function calls are expensive.
Yeah, I'll
And
agree.
eventually we got good at inlining, and now I don't worry about tiny functions because, as far as I'm concerned, the compiler will inline my tiny functions and I don't have to think about it.
Okay.
But I don't feel like we've gotten there with, say, async await.
Yeah, I'll agree. But I'm going to start by saying function calls should inline, and hand in hand is loops should optimize well, or else you start handicapped by 10x to 100x. Now, if you've gotten those done well and you still need more cores, you bring up the question of async await, multi-threads, joins and locks, and synchronization and overheads and all that kind of stuff. Some way to discuss all kinds of things. But if you start by saying, I'm going to ignore loops, you're handicapping yourself by 10x pretty easily. And I think that's a sort of a bad way to start. So the loop problem is sort of mostly solved these days, so we should solve it, which means you need to know graph theory. And that's where I got down here. It would be nice if async await had an answer that was known to be reliable and work for everybody, and that's not apparently the case yet.
I agree that it's not the case yet. I just don't really understand why.
Well, you should go write your own.
Like, why is async function so much harder to inline than function?
You should go write your own, runtime for your favorite async await language. I mean, I think one of the
I suppose that's true. Pain's a good teacher.
exactly. This is where it comes from. This is like Cameron's not here, but one of the goals for Ecstasy is to have this sort of painless micro parallelism, but in a more modern language than, say, I'm drawing a blank here. The 80s era telecom language.
Erlang.
Erlang. Just got to Erler. Yes, Erlang. Yes, exactly. So Erlang has some sort of model for fairly fine-grained parallelism based on channel communications. You could argue that you'd rather have microservices or whatever that's different from channel communications, but there's some model there, and they could do some optimization, and it's a very old language and has issues. Fine. Modern language, hey, it's not JavaScript, but something that says I have some microservices. But what happens for microservices in like the realms of like Java and C is that there's no starting point that says things are private. So the compiler just assumes everybody can see everything, and he's handicapped immediately what he can do. And then you say, well, wait, I'm going to inline A into B and into C into D, but the compiler doesn't see it as a C2 sees it as I have a giant mess of networking IO calls doing weird things with opening sockets and reading and writing, and I'm supposed to fold them all up and say, no, they just inline normally. No. So you need a custom compiler that does your microservices inlining. That immediately falls down the rat hole of I have to do everything in my custom microservices inlining guy as a normal compiler also does, so that I have a clue about what's useful to inline and what's not. Like a normal compiler has all this flow analysis that tells them types of things and values and who calls what where and what's dead and what's not. And if your microservices inliner is smart about it, but he doesn't have those pieces, he can't tell that this call he's trying to inline is all dead anyhow. And what the fuck is he doing here? He should be doing something else or whatever. He's wasting his time and energy. So he wants to have the same kind of high level optimization analyses that a regular compiler has, and also microservice smart inlining. This is an intrinsic. It's a microservice call to that guy over there. And there's a giant networking stack on the backside if I don't inline it. But if I inline it, it's just a function call. I should inline if it makes sense to inline. Okay. But that means you need a core optimizing compiler that also does a microservices inline. And that's part of the, the mindset going into ecstasy.
Wouldn't the more sensible thing to be to go the other way, to say, oh, I've got this function call and it's really expensive and it's all independent, and I'm just going to clone it and turn it into a microservice or something? I mean,
yeah, so that's actually really hard because you said it's expensive. Okay, what's expensive? Well, if you don't have profiling data, you're guessing. You're guessing typically on size. Bigger things are more expensive, right? Even if they start with if cached, exit with cache, and then they're actually never actually called and they're cheap. What the hell? And then the other one of that is it's all independent. Well, what's independent mean? I'm handing some arguments. They point to other things. Just point to other things. Point to 1,000 other things. And this function does a bunch of shit with a bunch of that stuff. When is that independent? And when is it not? In particular, if I have caching and I'm caching things locally somewhere, I have side effects. Go prove via escape analysis that cache doesn't escape and no one else can see the cache. Then it makes sense for it to be isolatable and hauled off to the side, made concurrent. This is like well beyond sort of the normal compiler technology.
Yeah.
So you don't get there by saying bottom up. You get there by flagging it. Take this dude and declare him a microservice. Immediately, I also declare that he has no inputs except his incoming args, and as a result, he has no state except what he manages internally as part of his caching. He doesn't mutate anyone else's state. No one else can mutate his state. All the isolation guarantees come. And maybe I'll prove them by nature of the language design that says you can't see other things. However, I write the language that says this microservice can't see other things.
That sounds a lot like the add copy for Smalltalk.
Yeah. I'm sorry, I heard add copy for smallpox, but yeah.
Smalltalk?
Yeah.
Everything's in it.
No, smallpox. I don't know smallpox.
Smalltalk, the language?
Small
very object oriented? Yes.
Yeah. Okay. Yes. Yeah. Right. Go prove that you can inline add. Turns out that's, it can be done, but it can get big quick. If you want to say microservice, it's usually a lot bigger chunk. And now you can't find it by looking at it as a compiler. You find it by someone annotated.
So what would inlining microservices look like?
Well, that's the thing that says, since I know it's a microservice, I'm going to ignore the program semantics as written, because the microservice, if I'm writing in Java, I'm writing my microservices in Java.
Mm-hmm.
At some point, I declare that I want to make a microservice call from A to B and then get a result back.
Okay.
And since I've written it in Java, where the first thing is I'm actually going to run it as a microservice, I'm going to write a request out to a socket. And it's going to go to a remote machine, which has a pool of these things. It's going to pick one, run it, and hand me an answer back. So from the compiler's point of view, he sees a ton of IO. Hey, open up the microservice finder guy. Go ask for an instance of a microservice that I've cached locally somewhere. Go open a socket. Go write some things. Go read some things. Da 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 da. It's a huge pile of shit. He's never gonna
There's kind of a dual approach when you can instead start with a single program, and it is the compiler's job to split it up into distributed programs. This is called endpoint projection. It's a fairly new approach. It's called choreographic programming.
I see your link.
Yeah, it has been invented pretty recently itself. If you scroll down, yeah, you can see that you write the communication for both the client and the server in one program, and it is the endpoint projection that splits this into separate programs, one for client and one for the server and one for the central authentication service. So it's the compiler job to kind of write the microservices for you, but you start with one monolithic application. And then the compiler can see the send, the receive, all the data flow, all the data communication, and can optimize it, presumably.
Yes. Well, this goes to my theory that you need to have the compiler told this is the microservice endpoint. And then the compiler can do something about it. I was headed for the point of you do an annotation and then the compiler ignores the code. Here, you don't actually write the code that does the endpoint thing, but the compiler is going to start injecting it if he discovers he wants it as separate pieces, I guess.
Mm-hmm.
Like this is about security things, the moment, as opposed to performance.
Right. And it's the compiler that introduces the sends and receives. You just kind of write the data flow and which service, which fetch, which data as input, which and output. But the sends and receives are also inserted and thus can be optimized by the compiler.
Right. Yeah, that's a key one. You mark points in the program where you think it makes sense to break out into a microservice or not. And then the compiler is choosing to inject. Yeah, I'm trying to claim the reverse where the compiler gets handed this shit and tries to unwind it is like hard.
Because then you have to reverse engineer this previous monolithic version to be able to optimize it.
Yeah. That's what I normally get, like C2 doing microservices on Java for Twitter. No, big Xbird won't unwind this. So they have to be flagged. And then C2 doesn't know anything about microservices anyhow, so he's not going to do that. So you need a microservice optimizer in the Java side of things, which itself can't know that much about things like constant arguments, and it makes sense to inline because it's all fast path cut out and be done, and it'll be done in 2 clocks if it's inline or not or whatever. Like there's a cognitive dissonance or whatever. There's disconnect between the C2 optimizer and the microservices optimizer as implemented currently in a JVM under a current sort of umbrella world. There is a different world somewhere where those two are not separate, like here, where you tell it, hey, here's a spot. And then the compiler says, well, I'm going to inline or I'm not. But if I not inline, I'll put in the wrappers to go send it off to a microservice. But if I inline, I'll blow all that shit off and just inline.
I mean, I would argue that's a lot of the value that the Erlang VM brought.
Yes. Oh, absolutely.
Like that's what the Beam was doing.
Yes. I'm not saying I'm thinking that Erlang has shows a history that can work there. Ecstasy wants to head down that path. Other languages could head down that path too. It makes sense. But you need
different. I've said a few times that people misunderstand Erlang when they think it's competing with C++, when it's actually competing with Kubernetes.
That's a good way to look at it. Sure.
There were some experiment by Google with the project Service Weaver, but they retired it. So they're claiming they're trying the model to write as application as a one monolithic binary and deploy it as a microservices. And they basically hide inside the interfaces. So the interface has to make the decision: do you call something locally, so like a virtual dispatch, or do you call something that is RPC away?
Right. There's a new web framework that came out in the Clojure world called Electric. I'll put a link here. And that one does something that looks kind of like this choreographic programming. And it actually runs on the JVM by Clojure and on JavaScript, because Clojure targets both of those. And you write one program, and then there's a sort of graph that it produces. It does some sort of data flow analysis, and then pieces together the parts that run on the server or on the host. And uh, apparently, it works well. There's a bunch of people who are building things using this, so it's kind of cool.
Yeah. Okay.
But I didn't realize that would be I was thinking about this choreographic programming and realized I think these are the same things. So it exists. People are using it.
The idea has been around for a long time, but there's some way to do
I think
this.
it's a bit different than
Been around
Erlang.
for a long time. Yeah.
Yeah, I think it's a bit different than Erlang, because in Erlang you're still writing one program which is the receiver and one program which is the sender, and they're separate programs. You write them in separate place.
I thought you
And
wrote them in the
this
same
electric,
like Java classes. You wrote them in the same project. And then
well,
just describing how they
yeah,
go.
it's the same could be the same project, but you're still going to have, one function that's sort of explicitly receiving stuff, and another function
Yeah,
that's
you're
you have to think about where things are and structure it accordingly.
You're explicitly drawing the lines between where the services go.
Yeah.
And what I
Whereas
just saw was you put a bunch of places in where you could have services, but you're not expecting them to all be a service boundary.
yeah,
Compiler chooses.
yeah, in this case, because there's a sharp distinction between host and the server and the client, then you do actually have fairly specific expectations of where things are going to go, but you still write it as one block of code, and it looks like a simple imperative piece of code.
Okay.
That's the idea. It's interesting.
Okay.
I haven't tried it out.
Yeah, I'd have to see, because I thought in Erlang you could put them all even in the same file, like the producer and consumer for sharing across could all be in the same file. But you had a clear distinction. This guy is a service provider, and people call him and they get an answer, and it's and nary the twain shall meet, or whatever. There's no inlining or not or whatever. Someone says, here's another one. We got another instance here. Where does this one come? This is somebody just doing a tutorial on it. Chlor. Oh, this is your Clojure library thing. Chlor? Is that what you said?
No, I put the electric link there, and then Matt.
Yeah, there's another one. I wonder how do they compare? I haven't used either.
Yeah.
So he's got borders that are implicit, and the compiler has decided to break it apart in this way.
This sort of ties to the idea that sort of MLIR goes there, where you've got something that works pretty much just like a compiler, but it's for slightly higher level concepts, and its idea is that it produces programs that you then compile.
Yeah.
And I would love to get to the point where I could play with those ideas using Sea of Nodes sort of ideas.
Yeah.
Because I think it would work.
Yeah.
I think the core idea here is to where to draw, what to consider a boundary. Here, I believe the boundary is considered a function call, but for example, service weaver or something considers the interface a boundary, which can be replaced either virtually or by RPC. But I think the function is the lowest thing that can be a boundary. So it's interesting to see how.
Well, functions are a normal boundary. So
Yes.
trying to say you're making a boundary.
So
Here they're not using function calls for the boundary per se. A sends to B.x, A sends to C.x. But I don't see a function call in this code. But the program says, I'm going to break out A and do a bunch of sends. This becomes a function call implementation. And somebody B is receiving from A and is receiving from C. And then here C is doing some local computation.
Yeah, I think that the idea is that you can express the overall logic that you want to,
Right.
you're aiming for,
Yeah.
and you don't need to split it up. And like the lower 3 blocks is what you'd have to do in Erlang.
Yes, I agree.
And the top thing is
Yes.
the new idea.
Right. This is A is a service and B is a service and C is a service, but I am talking about how I'm passing things back and forth between the services.
Yeah.
And then
You're never sort of localizing yourself as a programmer inside one of those services. You're more like you're like standing above it and sort of saying, okay, you're just like you're playing with toy soldiers. You're not the soldier.
Right. Yes. Yeah. Yeah. There has to be a better way than what's going on now.
Yeah.
All right. And Matt, you are being productive as usual. Here is mesh dialects, sharding communication on device mesh cluster. Yes, okay, that's
When you talk about there has to be a better way, I think one of the things that gets into trouble these days is that often the reason people are reaching for microservices is not that they want things technically. They want to be able to have team A deploy without team B's permission.
right.
So if you're going to have a structure that is your big microservice inlining thing, the ability to swap out a piece that is smaller than the entire system becomes very important.
So the whole notion of team A can push a new thing without permission from team B goes. This is a well understood, very long term understanding of like large programming systems have their important chunks broken out by teams, not by expected otherwise functionality. And those teams and the region of the program that they own and manipulate and work with are very static over time,
right?
Over very long
You
periods of time.
say, this is what I require and this is what I provide. And that's a well-defined boundary. And as long as you don't change what you require or provide, you should be able to redeploy your thing without talking to anybody else.
I guess what I'm saying here is that the nature of human communication pushes us into teams. The teams enforce a border that doesn't necessarily make sense, but they need it for the team's benefit.
Yes.
Right. And part of that we have to pay. I think having a very expensive interface to change is a very natural part of that team boundary.
Yeah.
But having a very expensive function call cost at that boundary is a lot less natural. I think it's totally reasonable for me to have made a change to my thing.
Yeah.
And that pushes out a notification to a whole bunch of servers that says, hey, this particular piece of code has a new version. Drop your current version, download the new bytecode, and re-JIT it into your things. And it may cause JITting to happen on other teams, but that call cost goes away.
That only works if the API is stable. You did a version change. Everyone who calls has to be API stable, and of course, there's Hiram's law kicks in on you too, and shit like that. So, I'm not saying don't do it. I'm just saying not so simple as, hey, I made a new version, push it. Yeah, right up until API has to change. There's a few stupid steps you have to take from this point to put to that part, and I ran them together behind your back, and I don't provide the stupid pieces in the middle because I don't like to, because it's hard for me to. And it's all more efficient, except that you still have code that says read from the bad thing and pass it off to the other guy instead of just taking the bypass.
Yeah. And if we went from this function was a pure function to this function is a closure, and suddenly there's shared state between multiple different services that didn't have shared state before. You've just significantly altered the performance characteristics of your system.
Yes. There are all kind of other fun things. I have a system that takes work at a certain flow rate and caches internally and keeps going, and it's good at this rate, but it does some small n squared work on the incoming stuff. And so if my queue's back up, the quadratic behavior causes me to get slower and slower until I blow up and die. So as long as you don't feed me too fast, I'm running at rate X. But you optimized your part. Now you're feeding me at rate 2X. I go quadratic and the whole system grinds to a halt and dies because you went 2x faster. And I have, yes, seen that before.
So for this purpose, inlining may you reduce the parallelism in the system when you try to group things together.
What I just said is the nature of network flow problems. I have some amount of producers. I go through a complicated network. Each piece independently takes, processes, consumes, and produces. It's called network flow. Chemical engineers see this all the time, as you might expect in an obvious liquid flow situation, but happens for any mathematical flow problem. And certainly microservices fall right in that category. And then as soon as you do that, you can go ask questions about network flow theory. And one of them will say, it's nonlinear. If I speed up over here, I could crash over there. There's all kinds of stuff. And I can make it linear by adding some extra properties that people typically don't do when they write microservices. So you get these instabilities. I sped up this, that guy over there overwhelmed and died. And the whole system as a whole took, less than 6 years. There's ways to fix that, but everyone has to understand what network flow theory is going to do to you and have to guarantee sort of monotonic performance, not just monotonic in the lattice sense, but monotonic performance. If I add more load, you only increase or you top out, but you never decrease. And if you force monotonicity across a bunch of people, you can get a system that as a whole has a monotonic through rate that is stable. If, on the other hand, you have a cache, say, that is using weak refs, and you take a GC cycle and the GC throws weak refs away to make space, that's a pretty reasonable thing. That's what weak refs originally went for. And you add some load to the system that's working well, and the GC cycles a little faster. He flushes things a little faster. The cache misses a little faster. You do the work to fill the cache a little harder. The work all makes more GC work that flushes the cache even faster, and you get a cascading fail and you die. So this is a system that could be very stable up to a load point. And then if you start getting more GC cycles and that heavily loaded, but not yet over the top server, he starts needing more load himself to maintain, doesn't have any way to maintain that load, doesn't have the horsepower, and his throughput drops off. He acts as if he's a freshly started service with an empty cache, and he's empty continuously. He never has a caching effect again. And the fix is to cut his load, then dribble it in, and he'll fill up his cache, and he'll take a high load steady, but you cannot go over X, whatever X is, or he will GC cycle, flush his cache, and sink down into the pit of despair again. Very nonlinear behavior. And yes, I've seen this and helped diagnose it, shit like that.
Oh yeah, we run on this kind of stuff when we deploy Zing in this kind of systems, and maybe this specific service started running faster, but then it just bottleneck moves somewhere else.
Yeah, if the bottleneck moved, you're good in the sense that you didn't go backwards, but you pushed the problem around. But if you fix all the problems that get pushed around, then everything should go faster.
Well, I think we've definitely seen cases where the overall performance degraded, and it was. I think it's what you described, that we just overloaded some other parts of the system which just were not able.
And they weren't linear. They went quadratic costs or something. Something happened to their cost model that went up when they got more load. The cost per unit wasn't linear. It was super linear, and then they failed. Yep.
My personal favorite story of improving the system makes it worse was Google had a huge number of MapReduces that they were running regularly. And they did a 2-year-long research project to improve the estimation of how long chunks of work were going to take so they could split the work more evenly amongst the nodes and get things to finish faster. And the result of that was it got dramatically better at splitting the load so that everybody finished at the same time. And then they all DOSed the network simultaneously and nothing could get through because the network was empty, totally smashed, empty, totally smashed. Yes. And the throughput of the system went way down because the network utilization got so much worse. Yes. So after they got really good at estimating, they had to get really good at estimating and then add jitter back in deliberately. So jitter.
I mean, you could do a sliding thing or something.
Right. You don't actually want to get everybody to finish at the same time. You want a batch of people of the size of the network bandwidth to finish, and then another batch of people of the size of the network bandwidth to finish.
Right. Yeah. Usually
But it
when
was
I
this
ran
great moment of like, we made it way better, and now it's slower.
doing things with H2O, we would have this kind of phase-oriented problem. And our fix was to generally just upscale the problem to doing, not solving one machine learning problem, but that's solving a hyperparameter search of machine language problems. And then you would get this jitter you're looking for, and they would spread the load out. And the time it would solve one problem could now solve 10 or 100 or something. Not much more time ever one would be, solve 2 or 10 because the bottlenecks got slid around. Yeah, that's interesting. But I have definitely seen the network slammed and nothing got through. And then people would fail for timeouts, so they would try again, and that would keep slamming the network. Network's busy. I can't send a packet
Oh
through.
yeah,
I can't
I've
open a
definitely
TCP.
seen the pattern of if you have 101% of the bandwidth you need, nobody ever sends retries, and if you have 99% of the bandwidth you need, everybody sends everything 3 times. And
Right. And now you need triple the bandwidth. You're already out.
it can
and then you
often take a
forget some
lot more bandwidth to
Yeah.
recover from having run out of bandwidth than it took to
Yeah.
not run out of
Yeah.
bandwidth.
Yeah, we eventually had to solve that one just the same way probably Google did, and we just put the exponential back off, but it was exponential. You tried and it didn't work. You tried and then you waited a while and you tried and you waited a while. Then you waited a long time. It's not dead, but it's not making progress. And eventually the network clears out, and then there were a bunch of late people that got there. Their exponentials were really big. Finally, doubled in a few more. Whatever. Fine. Yes,
Brian
there are a
Cantrell used to
bunch of
talk
issues
about
there.
every distributed system needs to take a vacation every once in a while.
Exactly.
Why did the system throughput just go to 0? It's on vacation. It'll be back soon.
Yes. Yep. All right. What else? We can be done. It's quite wet out. Guess I'm not taking a walk today. If I'm taking a walk, I'm taking a wet one. All right. I'm going to declare victory for the Alliance and walk away here.
I'm curious. For AA, have you thought at all about the idea of trying to inline across threads or having fork join as a fundamental part of the language?
No, I haven't put in a threading model. The experience I got out of H2O said that something along the Erlang model was a good idea.
So the thing I like best about the Erlang model is the idea of managers. To say, if this thing fails, choosing the right size chunk to restart.
Oh.
A lot of the systems I've looked at very much have 2 levels. Either we've managed to handle the error right here, or we restart the service.
Everything from scratch.
And they did not tend to be very good at resetting smaller chunks of things that got into bad states.
That's interesting. So that's under the model of it's going to
I think
fail.
in Erlang they call them supervisor trees.
Yeah, I knew that. But I didn't know. Right. But your claim is that you've seen uses where that's actually very useful. That the assumption is something fails, and the failure is not, when I say sort of localizable naturally to a small area. It's not like I ran out of disk or I just can't find a file. Like, why is find a file failure? Fine.
Well, you tend to have this game of like, okay, I was asked to process something that had bad inputs. So I got a crash and I sent a 500 back. Okay, I just want to blow away the one request and keep going.
Right.
But if it managed to corrupt the cache,
yes,
now I'm throwing a whole bunch of 500s for things that would have otherwise been valid, except that I've now got some garbage thing in a shared map for everybody.
Right. So there's a
my next thing I want to try is blowing away everything that's sharing that cache.
That's what I was trying to come up with. You're writing code that is defensive against programmer bugs. Like network IO bugs happen, crashes on the network, cosmic rays, bad sectors on disk. But you're saying there's a programmer bug level that I want to defend
And I tend to
against.
have these two levels of level one is serve a 500, that request was bad.
Yeah.
Okay, now keep going.
Right.
And reboot the server.
Right. You want something in between.
And there's not a lot in between where it's just like, I have a reasonable idea of what the caches are in this system. Maybe if I get several 500s in a row, I should just dump the whole cache and
Dump the
start
cache
again.
and rebuild.
But I don't need to recompile everything. Like,
right. Well, or restart the service, however long that takes to get started again.
right. And eventually, if I dump the cache and I'm still throwing 500s, then eventually I want to reboot that entire JVM.
Right. Right. Yeah. Yeah.
And I think it was really nice having the sort of threading model be tied to the supervisor trees in Erlang of what is the appropriate level at which I need to restart everything.
So the answer to your question was no, I have not thought about that.
So,
which again, I think is more of a standard library question than a language question. But
yeah,
your language is going to ship with a standard library. So
there you go.
one thing someone was talking about was about logging errors.
Yeah.
So someone mentioned that if you have a bunch of 500s in a row, maybe restart the server, but you'll know from the logs. I was like wondering, did you guys like have any? I heard a lot of stories. Do you guys know how to like log things well? Because I heard some stories where if you log everything, it's just going to be slow, and other stories is you should log everything, but you have it in a ring buffer so you can get like the last like dozen or last thousand if you want. Do you guys like have like any preference on how to log servers?
So I have a bunch of feelings or comments about logging in general. There's this theory that says I needed to know something, so I logged it, and then I mostly don't look unless there's a crash, and then I'm digging through. And then the next programmer says, oh, I need this other thing. And the next programmer says, I need this other thing. And pretty soon, 100 programmers are logging 100 random things. They can't find their own shit and everyone else's shit. And everyone agrees that 99.9% of the time, none of it's useful because it didn't crash in their shit. So then you're producing.
I forgot to mention. One of the stories was when you log everything, you don't actually keep it until there's a crash, and then you store it into a file, and then you can. So you
Right.
don't have that much information to look
Well,
through.
there's only so much you can hold in memory. So log4j is wildly popular and people furiously log using it. And I find it's mostly they're wasting their time, but they do. So fine.
I mean, when you say log everything, that's like the word everything is doing a bit of heavy lifting. I mean, the question is like, well, what do you mean with everything? I do agree that like maybe some like trace logs or like really, really fine-grained debug logs are a bit like maybe that's excessive. But I also think in many cases, I mean, many organizations don't really suffer from performance problems anyways. Like they're running on way too beefy servers for their workloads most of the time anyways. So but yeah, I do think it's a bit annoying like digging through the logs because you generate them, then you push them to some other place that ingests them. Like maybe you have some kind of Kibana or Elasticsearch setup, and then all the interfaces take long to load. You need to learn some kind of query languages, TSLs. Like it's not necessarily pleasant experience, even though some people swear by it. I think this is kind of like debuggers. Like people's opinions split a lot, and I don't know. I think actually one thing that's very underrated is dynamic instrumentation and just being able to like go into a production machine and start tracing stuff. I think that's like a bit old school approach that has been lost a bit. So yeah.
Adrian, have you ever tried dtrace?
So something like dtrace, yeah, that's kind of pretty cool. Actually, a lot of kernel tracing tools like I feel like they should be more utilized also for user space stuff.
It's
Yeah.
the turn it on when you need it thing as opposed to the
Right.
Yeah. Yeah,
And also,
H2O, just what Leva was saying, we would keep the last, I think it was 1,000 or 8,000 entries
Yeah.
of things that we expect might fail, which would be all the IO communications, like, parallel multi-threaded cluster scale out. So it was all the IO would get out of ordered and race condition or dropped and failed or whatever. So those were all kept, but very, very cheaply in a ring buffer. And then on a crash, you dumped it all out to a file and you got one file from every node in the cluster. And then we had a tool to go turn that into a timeline across the cluster.
Yeah. Also, I would appreciate the ability to tell the system to become more chatty, because if it's failed again, let's say in a production server, to tell it to log, to lower the log level to see more info.
Right.
And but that does require you to structure the things, to have approach on what is important and what not.
I certainly lived in the era where people started running long-lived, long-running applications that logged heavily. And then, for instance, they would run out of disk space. And then you couldn't get in on this box because in order to open a shell, you needed some memory, you needed to swap, and the disk was full, and whatever weird things happened on you. And you go delete a bunch of shit, and the log was producing a gigabyte a second. So you got a few seconds of lifetime after you deleted a ton of stuff, only to discover that you still know who's logging and where it's logging to, but it's just spewing hugely and whatever, all kinds of problems with the IT guys trying to do support on systems that log furiously. And I think things are better maybe now. I haven't heard so much bad news recently. Like you always end up logging in a ring buffer, maybe on disk in a ring buffer, but you cap the size of the log to avoid just drowning yourself in log bits.
Yeah, the usual way that I see that ring buffer implemented is you have something that's logging to disk. It's got a rule that says cut the file after so many megabytes. So every 64 megabytes of logs, it starts a new file. And then has a rule that says once you have 30 files, every time you make a new file, you drop the old one.
Drop the right.
So you get effectively a ring buffer.
Yes.
And then you often have some other system that's trying to zip up and ship off those things faster than they fall out. Except that if it gets behind, it just gets behind. Like just we're not going to fill the disk because you're behind. We're going to miss one of those.
What did you do with this endless supply of 64 megs of log that no one's reading? Oh, why were you bothering to catch it? You're paying somebody some money to zip them up and ship them off. And where do they ship them to? Oh, Amazon Cloud. You're just paying for your Amazon buckets then. Fine.
Put them in a time capsule and somebody in the future will be interested.
Exactly. Somebody in the future. Right.
But the thing is, it's very easy if you're not careful to have most of the CPU usage of your application be formatting the strings for the logs.
Yes. There's a lot of cycles get burned there, including things like assert some expression is true, except that you had to compute the fucking thing, or I'm sorry, print. It fails. It's assert expression and then the log message if it fails. And then the compiler comes along and says, well, I have to go compute this string concatenation of the error message in case I fail. Come on, guys. No, stop it. You're hurting me.
So I saw logging go through several generations while I was at Twitter. First, people were just logging strings, and it turns out it's really hard to work with those strings. So then we got big into structured logging, where it said, okay, every log line will be a JSON document, and we're going to encode all the new lines that appear as /n, so that it's exactly one line per log line. And now all the logs were these JSON objects, which improved the ability to process logs a lot and bind things a lot. And then we realized that this thing that was using the most CPU in all of Twitter was turning integers into decimal strings for logs, because a lot of what we logged was numbers. So we switched to logging thrift structures instead of JSON documents, which meant that we could leave an integer as 4 bytes as opposed to trying to convert it and leave a timestamp as an integer and leave floats as floats. And that dramatically reduced the cost of logging across the entire system. And then eventually you realize that most of your log lines are almost identical shape to each other, even if they're all thrift. Right. So those could be encoded as a Parquet file and stored as a columnar store.
Right.
So the idea of, as you're logging, log out thrift structures. And
And then
rather
you
than
discover-
reading back in that file, keep it in memory. And once it gets to the appropriate size, make a column or store, write it out as a parquet file, delete the thrift without ever having read it back in because you built your parquet out of what was still in memory.
Right.
And then the stuff that you ship back to be log analyzed is just these parquet files that are,
And then you find bugs in
you
your
know,
logging
a tenth
infrastructure.
the size of the thrift files that were half the size of the JSON files.
Yep.
So you can build arbitrarily complex logging systems
Right.
if you need to.
Well, you have to go
I hope
debug
you
and
do.
engineer
Yeah.
and deal with all that. And then it was only useful if somebody read it back in less amount of engineering effort than it took to save it all. So one of the things I did at H2O was I pushed back on a bunch of the junk logging, and then I demanded engineers put their 3-letter initials on every line that had their private log info and grep. You know, we just had to cycle. We couldn't write infinitely, so you had to cap, just like you said, 64 megs, whatever it was. But then you could grep, and then you could say, "Gosh, Tom, 90% of the log
So we
is your
never
output."
implemented that, but we did have a discussion of a logging library that required you to put a budget ID into every log line.
Yeah,
That said, okay, who's responsible for paying for this logging?
that's correct. That's correct.
And then you could send each 10 team a bill at the end of the
Yeah.
month. It's like, here are the 6 log lines that are costing you the most money. Can you
Yes.
not?
And you're emitting a few billion a second. Maybe you should rethink this. Yep.
Have any of you had success reproducing error through log files? I rarely have them, but it does happen.
Right. So they were occasionally useful, far less than I claim the amount of engineering that went in to make them sensible. I found the internal log I did for IO, which was super lightweight and just recycled in memory only, was required on a important set of bugs. There was no other way to debug those bugs. So that one was absolutely required. And then once it was done, it wasn't very much effort to keep lying around, and it didn't burn endless cycles like what Aaron just went through.
Yeah.
It's
I think
literally stored a word of the nanotime and a word of the, a 64-bit line of the event information, and the reconstruction afterwards is where, if you needed the reconstruction, that had some effort to it.
I think I think it's one thing to, you have a bug, so then you build some logging and you may or may not keep that logging. But I think a more interesting question is, did you ever discover a novel bug that you were able to debug with pre-existing logging?
Oh, really rarely. You would get bugs and the log would point you in a direction, and then you would discover that was floating around and you could now reproduce it some other way. There are no more than sort of a very high level starting point.
So the one that comes to mind for me is that Twitter logged a whole bunch of the user generated string situations where stuff would go through and cause crashes. And it turned out there was someone who was tweeting messages that had characters that were valid UTF-8 characters that had no valid UTF-16 equivalent encoding. And when it went from the node systems to the JVM systems, and the JVM tried to turn them into UTF-16s, the string from bytes was blowing up in such a way that was very difficult to detect what had happened. But because we had this high level log that was like, what are the tweets that caused crashes on the downstream systems? We were able to tell that the problem was if the upstream system had a thing that was not encodable as UTF-16, but was encodable in UTF-8, and the downstream system couldn't process it, it would just not respond because it went into this black hole of an error, which was causing timeouts in the higher system. And logs helped us correlate those two systems to figure out what was happening on that boundary.
Right.
One thing that I miss.
Also, you shouldn't tweet strings that look like that. That's just mean.
One thing that I really want to see is the logging tracking transformations, because that is the most useful things. That data becomes into that JSON, becomes into that Thrift, and becomes into that SQL query, and that would relay most of the data that you want for in order to narrow down the problem a lot.
Logging
Again, you don't need to store
high-level
these things
phases.
forever.
Yes, but would it
When
be
I got
useful?
something out of an H2O log that was useful, it was almost always a high-level phase. And one of the high-level phases would be a data ingest. I ate a 10 terabyte file in, and then I ran out of memory and died. Well, okay, so you got to have at least 10 terabytes of memory free if you're going to need a 10 terabyte file.
Problem is that you end up with a 10 terabyte log message.
Oh, the logs got like stupid. I hated it. Fine. Yes, you could get a 10 terabyte log message. Not out of H2O. We put caps on that at some point pretty quick.
Has anyone else noticed that a lot of the JSON libraries, if you run into a JSON parse error, will not actually tell you the byte at which the error was, but the mod 2 to the 32 of the byte where the error is? And suddenly you're looking at a spot and you're 4 gig away from where the error was in your JSON object? Because I find that a lot of JSON libraries are really not tested well with JSON objects that are more than 4 gig.
I can believe that.
I didn't realize there's anything that use 4 gig JSON objects.
At what point
Not
is
good
JSON
strategies
object
for backing up a
self-applied?
database.
Yes.
Wait. Is this like base encoding, base 64 encoding all your binary?
No, I heard JSON of a database backup.
Yes,
Yeah, but
that's what
aren't
I heard too. JSON
Yeah, if you have a
representation of
key
your
value
database.
store and it's got a billion keys in it, and someone decides that the appropriate way to dump the key value store is as a JSON object, because
Right.
both the keys and values are strings.
Oh, geez.
Oh, they're strings, they're not binary data.
I believe in this case the database was string to string data. And they
Okay,
were backing it up as a JSON object, which worked
Anyway, you
really
can-
well for the original design of the system when they thought it was going to be small, but then it ended up not being small.
Anyway, that's what base 64 encoding is for.
I just disaster after disaster. All right, we're off to systems disasters. I'm gonna call it here.
That's why we should all switch to base 85. That'll solve the problem.
Yes, base 85. As soon as I grow 8 extra arms and legs, I'm all good for that.
More mods.
UTF-16, you could go way higher bases than that.
Stop while you're behind, because you're getting behind her. All right. Any last words of wisdom here before we call it off? All right, done.
Don't mess with databases. That's all I learned.
Yes. Well, not with ones that are, never mind, more than 4 gig entries. Fine. All right, till next time. Bye.
Right.